Hello. Today we are going to be looking at solving exponential and logarithmic equations. As Jacob pointed out earlier, on the last assignment we solved some. The first four were solving logarithmic equations, but we were writing with a common base. This is stuff we did on Thursday. Solve logarithmic equations. We've also solved exponential equations this semester. With exponential equations, we did them using a common base. On this assignment involving exponential functions, that's a proof score. Let's see, right out here. We started solving these equations. We were writing both sides with a common base. Like here, we'd rewrite the 81 as 3 to the 4th. That common base stuff. But here, we could write 9 as 3 squared. And then say if the bases are equal, the exponents are equal. Now, I wonder why I'm looking at that rather than flipping through the notes from that day. Yeah. Look here, we had some properties of exponents. And then, right up here, at number 17, we rewrite the 16 as 2 to the 4th. And so if the bases are the same, the exponents have to be the same. We also defined that irrational number denoted E, 2.7, 1828, 1828. I think the next two digits are 4, 6. We said if we have an equation that has an E on both sides, that's the common base. And at the time I was saying, now what if there wasn't a common base? Instead of 16, suppose it had been a 3. If you have a 2 and a 3, there's no way you're going to get a common base. We're about to answer, what will we do then if we can't get a common base? What if just one side has an E? So, this is solving exponential and logarithmic equations. To solve an exponential equation, in which there's no common base, it's going to sound sort of strange. To solve an exponential equation in which there's no common base, take I'm going to write it with a capital L, although you would never type that on Pearson. Take the natural logarithm of both sides. That's the first thing you do. Second thing, use the power rule of logarithms to carry down the exponent. So, use the power rule to carry down the exponent. Then, that's the exponents. There's probably going to be exponents on both sides. Step 3. Isolate the x value. Note, if there's more than one x value, there is more than one x value, Isolate them on the left. Factor out the x and divide. This is a general strategy for how we'll solve exponential equations when there's no common base. If there's a common base, that's the easier way to do it. Okay? We're going to be using that key ln. I think we used it on our calculator the last time. It is right there. Okay? But let me give y'all a chance of writing that down. And okay. So we're going to take the natural logarithm of both sides, carry down the exponents, and then you're going to have to isolate the x. Let me find the problem, because I think I'm still on the wrong assignment here. What is that? Exit. Oh, let's just say cancel and save it. Okay. Now, the assignment we're actually on is right here. And let's look at problem number 1. 2 to the x equals 6. Do y'all agree that we can't get a common problem 1? There's no common base. If it had been maybe a 4 on the right instead of a 6, you could think of the 4 as 2 squared, and it'd be very easy to do then. But how do we solve it if there's no common base? That's what I'm trying to illustrate here. Okay. First thing we do, take the natural log of both sides. Really, all you're going to do is stick an ln in front of each side. I want to recopy this problem, spreading it out. So I'll have room to stick ln in front of both sides. Okay? So that's step 1. Take the natural logarithm of both sides. Then step 2, use the power rule to carry down the exponents. There's only one exponent. With logarithms, if you have an exponent at the end, you can move it down in front. So it'll be x ln 2 equals ln 6. Now, isolate the x value. We don't need to worry with this purple note because there's only one x value. It's if there's more than one x value, you've got to use the purple note. So let's see. What would I do to get this x by itself? This is x times ln 2. So thinking of ln 2 as just a number or another variable, what would you do? I'll give you the hint. Am I going to subtract ln 2 from both sides or divide? What would undo that?
Divide?
Yeah, divide both sides by ln 2. And the ln 2's cancel. So we have x equals ln 6 over ln 2. The answers here is going to be messy decimal numbers. We haven't been using a lot of decimal numbers this semester until now. In order to punch this in, if your calculator is like this one, pay very careful attention to the parentheses. When I hit ln here, it opens the parentheses. So I've got to put a 6 and then close the parentheses. I think I mentioned this idea of always closing the parentheses the last time. If your calculator opens them, then you close it. ln 6 divided by ln 2, close parentheses, enter, and I don't remember how it said to round it. Let me see. Round to 4 decimal places as needed. Okay. 4 decimal places. Oh, x. I'll just put some wavy equals, which means I'm rounding. Okay. 2.58, and then we have a 496. If I wanted it 4 digits after the decimal place, I'll write 58. Am I going to leave it as a 49 or make that a 50? Yeah, the digit after the 9 is, if it's 5 or larger, you round up. If that number after the 9 had been a 4 or smaller, you would just drop all of that. But it's going to be 50. 2.5850. So 2 to the 2.5850 power would give us a 6. Let's see. Oh. Any questions there? Stick ln in front of each side, carry down the exponent, and then it's just a matter of isolating the x, which is 1x, so divide by ln 2. So if I put in 2.5850, check the answer. Now, I think these usually give you the option of there not being a solution. That would happen if when you punch the stuff into your calculator, you had gotten an error. Like if I had ln if I punch that in, it gives you an error, not a real solution. That's when you would choose answer B. But as a general rule of thumb, if that's it, you punched it in wrong. Okay? Theoretically, if your calculator says non-real answer, then okay, choose option B. But I've never actually seen these problems regenerate so that that's the correct answer. Usually, if that's what you're getting, this answer here, that means you punched in something wrong. Okay? Now, number 2. Okay. Problem 2. 5 to the 6x minus 2 equals 2 to the x. So solve this equation. 5 to the 6x minus 2 equals 2x. Could we get a common base? Absolutely not. There's no way you're going to write 5 as 2 to a power. Okay? If the 5 had been a 4 or maybe an 8, then yeah, you could do it with a common base. But if it starts talking about rounding decimals, that's its way of telling you it's not a common base. Okay? Oops. So let's do this one. Oh. Take the natural logarithm of both sides. So by that, you just stick ln in front of each side. Then use the power rule to carry down the exponents. Here there's exponents on both sides. So you carry down the 6x minus 2, and I'm going to put it in parentheses, keeping it all together there, and then ln 5 equals, just carry down the x, ln 2. This is going to be some messy manipulation, unlike problem 1. Because we now need to isolate the x value. Well, there's more than one x value. So how do we isolate them? We're going to have to put the x terms together on the left side, factor out the x, and divide. Well, first of all, we're going to have to distribute this ln 5. Multiply both of those by ln 5. It's going to look worse than it really is. It's just 6x ln 5 minus 2 ln 5 equals x ln 2. So when I distribute this ln 5, I'm just putting ln 5 at the end of each one of these terms. 6x ln 5 minus 2 ln 5, as if I were just distributing a variable. If it were to distribute y, 6xy minus 2y. Now, we need to move these x terms around so that they're isolated on the left side. So I'm going to follow this arrows. I'm going to move this x ln 2 over to the left. And I'm going to move this negative 2 ln 5 over to the right. So we have 6x ln 5, then a minus x ln 2 equals 2 ln 5. There's more than one x value. Isolate them on the left. I've done that. The two x values are on the left. Now factor out the x. So we're going to factor this variable out of each term. I would write x. I'm just factoring the variable out. And if I factored an x from each of these, all that would be left is a 6 ln 5. Then this minus is that one right there, ln 2. If you just covered up the x's, whatever's remaining is what's in the parentheses. So if there's more than one x value, isolate them on the left. I've done that. Factor out the x's. I've done that. The last thing to get the x by itself, divide. Just go divided by all of that. 6 ln 5 minus ln 2. Divided by 6 ln 5 minus ln 2. Now the x is by itself, and you have something you've got to punch into your calculator. Okay? Punching this into your calculator is not necessarily a trivial task. Since I'm out of room, let me write it over here. So we're going to have to punch this into our calculator. And in general, when you punch something like that into your calculator, if there's more than one number on the top, you need to enclose it in parentheses. Like here, there's two numbers, a 2 and the 5. Okay? I think I'll just keep working with this. If there's more than one number on the top, that needs to be enclosed in parentheses. So I'm going to put parentheses around the top. If there's more than one number on the bottom, 1, 2, 3 numbers on the bottom, it has to be enclosed in parentheses. If you're wondering why is that, just stop for a moment and think about, and this what I'm writing right here, you don't need to write down. Okay, you'll wonder later, what the heck was he talking about? If I had 6 plus 4 divided by 2 plus 8, could y'all, let me move my calculator. 6 plus 4 divided by 2 plus 8, y'all can do that in your head. It's what over what? Maybe you can't do it in your head. 10 over 10, so the answer should be 1. If I punched into my calculator 6 plus 4 divided by 2 plus 8, we know it should be 1, but it's sure not given a 1. Let's see, what is it going to do? A 16? Yeah. That order of operations, please excuse my dear Aunt Sally. If you don't have this stuff in parentheses, it's going to do that division. 4 divided by 2 is 2, and then add. That's why it's getting 16. In order to make it give you the correct answer, you've got to have the top in parentheses and the bottom in parentheses. Then it does 10 over 10 and gives you 1. Why am I saying that? Well, I'm trying to justify my statement that I made just a moment ago. If there's more than one number on the top, you've got to enclose it in parentheses. Now, on my calculator, every time I hit ln, it opens parentheses. So that's going to give me another set of parentheses. When I hit ln, it opens the parentheses. I've got to close them. That means I'm going to have to put 2 parentheses here and here. If you don't put those 2 parentheses, it's going to give you the wrong answer. Right here, every time I hit ln, or at least on my calculator, if I hit ln, it opens the parentheses. That's why I've got to have these parentheses around the 5, around this 5, and around this 2. If you don't put the parentheses, these parentheses right here, it's going to give you the wrong answer. So I'm going to punch it in parentheses 2 ln 5, close, close. You've got to close it for the ln and close it for the top. Divided by parentheses 6 ln 5, close, minus ln 2, close for the ln, and close around the bottom. 0.35911. How is this telling me to round it? Oh, just to 3 decimal places. Okay, so 0.359. Is that how y'all would round it? 0.359. Okay. Very careful. Now, if your calculator, when you hit ln, if it doesn't open the parentheses, then you don't have to worry with closing them. Okay? Depends on how your calculator works. But on something like this, an old-fashioned TI calculator, no touch screen, it opens parentheses, you've got to close them. So, let me punch this in. 0.359. Okay.
Would that still say 0.36?
Huh?
Would that still take 0.36, or does it have to be?
No, it doesn't have the 3 digits. It's going to count it wrong. Okay? Here's another one. Problem 3. Let me write it down. 6 to the x plus 2 power equals 4 to the 2x minus 1 power. Here it says round to the nearest thousandth. Digits after the decimal point are tenths, hundredths, thousandth. So this one is another one where we're going to round just to 3 decimal places. That's what it means by the thousandth. Definitely there's no common base. You can't rewrite 6 and 4 with a common base. If it had been 16 and 4, then yeah, you could write both sides with a 4. But you stick ln in front of each side. Carry down these exponents. So we would have x plus 2 ln 6 equals 2x minus 1 ln 4. This is a messy manipulation here. Right? Now we distribute the ln 6. So it would be an x ln 6 plus 2 ln 6. Over here, same thing. Just stick ln 4 after each term. 2x ln 4 minus 1 ln 4. So I'm following those sequence of steps that I wrote out. Take the natural log of both sides. Use the power rule to carry down the exponents. Now, I had to distribute. Now I have 2x terms, so I'm going to isolate the x terms on the left. By doing that. Moving this 2x ln 4 over to the left. And I'm moving the 2 ln 6 to the right. So we have x ln 6 minus 2x ln 4. I know this is a messy manipulation, but this is about as messy as it's going to get. I'm always an optimist, thinking things could always be worse. I'm going to move this 2 ln 6 over there, so it'll be a negative. So negative 1 ln 4 minus 2 ln 6. And now, factor the variable out. Those x's that I circled, just write it down. And then in the parentheses goes whatever's left up there, ignoring the x's. It would be ln 6 minus 2 ln 4. Okay. And there's just one thing left to do to get the x by itself. What am I going to do now to get the x by itself? Divide, yeah. So divide both sides by ln 6 minus 2 ln 4. And you're going to have something really messy to stick into your calculator. The top and the bottom should be enclosed in parentheses for the same reason that you have to enclose the top and bottom when you're looking at 6 plus 4 over 2 plus 8. Now, on my calculator, am I going to have to put in more parentheses? Yeah. Every time there's an ln, the number after it, I have to have parentheses. If you miss one of these parentheses, you'll probably get the wrong answer. The only ones that you can mess up on are the very, very last one. If you forget either of the last two answers, most of the calculators, TI-84 and lower, will still give it. But if you have a higher number than that, it might say syntax error if you don't put these two parentheses. So let me. Because I'm punching all of that. Parentheses. That's a -1. So I put here, this is the negative key. That's the subtraction key. So -1 ln 4. The parenthesis I'm just now about to close is this one right here. Then a -2 ln 6. Close, close. If I don't put both of these sets of parentheses here, I'm going to get the wrong answer. Divided by parentheses ln 6 close. Then a -2 ln 4, close, close. And we're rounding this to 3 decimal places, so 5.06, what? 5.06, am I going to leave it as a 6 or make it a 7, that next number? I'm thinking 7. Do y'all agree with 5.067? If you tried to punch that into your calculator, did y'all get the same thing? You've got to watch those parentheses. Let me go ahead and stick it in and then I'll bring it back, but let me punch it in so you'll see it's the right answer. And oops, come back over here. Any questions there? This is probably the most involved problem here in this assignment. Okay. Any questions? Problem 4, at first glance you're going to think, oh wow, it looks even worse. But no, it actually isn't. Let me solve for t. And there is that irrational number e. 2.718281828. You're not going to do anything with that 2.71828. It's e to the negative 0. Is that a 5,1t? Equals 0.82. Well, we had said a week ago if you have e's in your exponential equation, you needed an e on both sides if you were going to have a common base. And here we don't have any common base. We don't have any e's on both sides. Okay? But that's fine. We'll just follow those steps that I wrote, and it's going to work out pretty nicely. Take the natural log of both sides. if I stick ln in front of each side, you're going to need to remember a rule that we stated the last time. It was the last assignment, or the last problem when we were working with natural logarithms, problem 20, our first assignment of logarithms. We had the rule that if you have e and ln side by side like this, they cancel out. In other words, ln and the exponential function e to the x are inverses. If you look at this rule I have right here, where the ln and e cancel each other out, what am I trying to say is about to happen right here on the left? Yes. So we just have negative 0.51t equals ln 0.82. Oh, wow. After doing number 3, this one is actually one that you can impress someone with because it looks really hard, but it's not that bad. Because I only have one thing left to do now to get the t by itself. What will I need to do to isolate the t? Divide. So dividing both sides by negative 0.51. That's the stuff we got to punch into our calculator. And there's only one number, that's 0.82 on top, so I don't have to put the parentheses around the top. It wouldn't hurt if I did. I don't have to put parentheses around the bottom. There's one set of parentheses we've got to do. When I hit ln, it opens the parentheses, so I'm going to have to close them like that. So I'll punch in ln. Let me pull this up. Clear it. ln 0.82. If you don't close this parenthesis right here, you'll get the wrong answer. Divided by, now this is a negative, not a subtraction. So here's the subtraction key on my calculator. The negative key is the thing that's in the parentheses. Negative 0.51. Enter. Oh, and I didn't look to see. How do they say to round it? Round to 4 decimal places. Okay. So, wave it equals, meaning just approximate. So if I'm rounding this to 4 decimal places, 0.38911. So it's going to be 0.389 what? What will I put after the 9? Do I leave it as a 1 or make it a 2? Leave it as a 1 because the digit after that 1 is another 1. Okay? If the digit after the 1 had been a 5 or larger, you would round it up. Okay? 0.3891. Definitely problems 2 and 3 are the messy ones out here. Okay. And just to make sure that it's clear, if you're thinking I'm mistaken, all I'm doing is I'm punching it in incorrectly by not closing the parentheses. Am I going to get the same answer? No. Oh, well, heck. There it is, non-real answer. If you get that, more than likely you've punched it in wrong. Okay? Okay? If you find yourself choosing this as the answer, you've probably done something wrong. Okay? Let me see. Go to. Yeah. Okay, I'll clear that out. Any questions over those first 4 problems? Now, there is something about logarithms that we should mention. It doesn't matter if you're using the ln key or the log key. You can never have a negative number after a logarithm. Okay? You can never have a negative number. If I go log negative 10, okay, what we're about to start doing we're now going to start solving logarithmic equations, and we sort of hinted at this the last time when we were doing the first 4 problems. Okay? Let me write this one down. Log base 4 of 4x minus 8 equals, gosh, I wish there hadn't been so many different 4s to keep track of them. I'm putting them different numbers. So we're through with this stick the ln in front of each side. Okay? Those are the ones you do. That's what you do if you have an exponential equation. By that I mean variables in the exponent. Okay? If there's a variable in the exponent, that's when you stick ln in front of each side. Here we have logarithmic equations. It's an equation that has a logarithm in it. And what you're going to do is try to get the x by itself. And the way we do that is by first canceling out this log base 4. What number would I need to put right here that would cancel out that log base 4? Well, another 4. Okay? We have that rule of logarithms about the common base. If the big base and the small base are the same numbers, then those cancel out. That was something we stated right off on the right here. Log base b of b to the x. If you have the same number here and here, then it cancels each other out. Like here on this problem number 4, it was log base 5 of x equals 2. We put a big 5 on each side to cancel that out. That's what we're doing here. Put a big 4 on each side. And it's sort of bad that we have so many 4s occurring. What I've just done now is that gets canceled out, leaving the red 4x minus 8. And on the right-hand side, that's a 4 to the 4th. Don't say 16. If we multiplied out 4 4s, what are we going to get? Is it 256? That's the same thing as 16 times 16. On here, if I went 4 raised to the 4th, 256. And now, can I isolate the x without too much trouble? Yep, I would need to add 8 to both sides. So I'm adding 8. And I have 4x equals, what is that? 256 plus 8, is that a 264? And then divide both sides by 4. $264 divided by 4, that's going to be what? 66? Any questions there? When you're solving the logarithmic equations, you don't have the decimal numbers. Okay? You're just going to have some whole numbers or fractions. So 66, let me punch that in. Now, on these particular problems, it is theoretically possible that you might get an answer that's not a real number. Okay? When will that happen? Well, if your solution gives you a negative number after the logarithm, mark it out. It's possible you might get a number that's not really a solution. Okay? And from here on, every time I do one of these, I'm thinking to myself, if I plug the answer, if I plug 66 in for x, 4 times 66 minus 8, is that going to give me a negative number? Well, no. So 66 is the answer. Usually, it's if you get a negative number, you better be real careful and check and see, because you might have to mark it out. And hopefully that'll happen on the next one. Okay, so that's problem 4. Is that the page you want? So we could handle it if it says one logarithm on the left equals a number on the right. That's how problem, the one we just finished doing looks. There was just one logarithm on the left and a number on the right. The natural question to ask is, well, what will we do if there's 2 logarithms in the equation? So we know how to do it if there's just one logarithm. Just put whatever this little base is, just put it on each side. I'm not going to do this, but let me see. This would have been a better example. I'm not going to write it down, but what big base would I put on each side? A 2, okay? Well, if you ever get this, always save the best score. See, I'd regenerated it. So how does number 6 differ from 5? Well, here on number 6, there's 2 logarithms. We know how to do it if there's just one logarithm. This is a classic application of the most fundamental problem-solving strategy. If you know how to do one problem and you're confronted with a new one, make it look like the old one that you know how to do. This says log x plus log x minus 15 equals 2. We know how to do it if it were just one logarithm. If this log x minus 15 weren't there, or if the log x weren't there. So what can we do? Well, the last time, do y'all remember condensing logarithms? That's how you take 2 logarithms and write them as one logarithm. I would write log, and whenever I'm condensing logarithms, I always ask, is there a fraction? And you determine that by the minus sign. Do I need to flip back to some of that stuff we were doing the last time to try to jog your memory? Let's see. I should have already Like here, problem number 10, we're condensing logarithms. If there's a minus sign, then that's the stuff that goes on the bottom. This might have been my Monday, Wednesday class there. Let me go back. Oh, well, I think some of those condensing, they were just things that we were able to just do it without having to write it out. That problem, let's see, is 13. To condense it, since there's a plus there, there's not a fraction. The number in front of the letter L is the exponent. So that's where we get the x to the 1/6 and the y. Over here, if we're going to condense this down to just one logarithm, you ask yourself, okay, is there a fraction bar? If this plus had been a fraction bar, a minus, then there'd be a fraction bar. So instead, we just have that. X times x minus 15. If it had been a plus, you'd go over. Now, something else from the last time. If the base isn't stated, notice there's not a little base here. What base do we assume it is? A 10. So we got to assume that's a 10. And now it's very similar to problem 5. What big number am I going to put on each side to cancel out this log base 10? Big old 10. So all of that cancels. And on the left we have x squared minus 15x. See, I have to distribute that x. Equals, don't say 20. This is a 10 squared. What would that be? What number are we going to have over here on the right-hand side? 10 squared, 100. And it seems like it's been a while since I've solved a quadratic equation in here with y'all. An x squared means there's a quadratic equation, so get a 0 and factor. So I'm going to subtract that 100. This is that stuff that we did right at the beginning of the semester, and it keeps popping up all semester. The way this stuff builds one after another. That's why the course is structured, where you've got to work through it one after another. Let's see. To factor this, numbers that multiply together to give 100. Well, 1 times 100, 2 times 50, 3 doesn't go into it, 4 times 25, 5 times 20, 10 times 10. I think I've listed them all. Which of these pairs of numbers is going to work to give us that 15x, that's the middle term? 5 and 20? Yeah, you put x and x. 5 and 20. How do I need to arrange the plus and the minus sign in order to get a negative 15x? Because it's got to be negative. A plus and a minus, because that second sign is minus. Plus 5 and minus 20, is that what I heard? That's right. Now that you have it factored, set each factor to 0. And we get x equals negative 5. And x equals, is that going to be a positive 20? Now, if you go to Pearson and type in negative 5 comma 20 as the answer, it's going to count it wrong. It probably won't give much of a hint as to why it's wrong, but, oh, let me lower this page. Why are they going to count it wrong if I list both of those numbers, -5 and 20? If your solution gives you a negative number after the logarithm, mark it out. If you plug a -5 in for x, aren't we getting a negative number after this first logarithm? And right here, if you put a -5, -5 minus 15, that's a -20. But if just one of them makes one of the logarithms negative after it, you've got to mark it out. We would get log negative. Primarily, it's if you have a negative answer, that's the one you mark out. Here, if I plug 20 in for x, we have log 20. That's fine. It's a log positive. Right here, 20 minus 15, are we getting a positive or a negative number after the logarithm? Positive. So 20 is fine. The -5 is not. So if I come over here and type in. Now, if we had gotten 2 negative answers, then you would have had to say, okay, the solution is the empty set. But we didn't get 2 negatives. Where is that? Any questions? So, if we have 2 logarithms on the left and a number on the right, if you have 2 logarithms on the left and a number on the right, you know what to do. Condense it down to just one logarithm and then cancel out that logarithm. Well,
Is that equal to, or whatever number that's going to be, would that be the power?
That would be the power when you actually, you see, when you stick the 10, once you start canceling it out, that 2 becomes the exponent. That becomes the power. Okay? Just like over here. Oh, well, this number 5 where there were so many different 4s, once you put the big black 4, that green 4 becomes the exponent. Okay? Number 7, it just gets progressively more involved. Okay, using that problem-solving strategy, make it look like something you know how to do. We know how to do it if there's 2 logarithms on the left and a number on the right. What am I trying to say we need to do to number 7? We know how to do it if there's 2 logarithms on the left and a number on the right. Can we somehow make this problem look sort of like number 6? If there's just a number on the right and the 2 logarithms are on the left, let me write this one down, and then y'all can try to tell me what I'm trying to hint at that we're going to do on this one. Log 7x plus 9 equals 1 plus log x minus 2 . Okay. We know how to do it. We know how to solve it if it's log on the left, number on the right. What am I trying to say that we need to do on this one?
Take that on the right and move it.
Perfect. Get the number by itself by moving that logarithm. It's going to change this sign. It's not going to change the x minus 2 sign. It's going to change this plus right here. And you might think, oh, a fraction, so it's going to be harder. Actually, I don't think so. Log 7x plus 9 minus log x minus 2 equals 1. So the strategy here is to make that problem more like number 6. Put the two logarithms on the left, and now let's condense them. When you're condensing logarithms, the first thing you ask is there a fraction bar? Because of this this minus sign, there's going to be a fraction bar. Okay? Because of this minus sign. The 7x plus 9 would go on top. The x minus 2 on the bottom. Do you remember that condensing, the way we were writing them as just one logarithm the last time? So once we have it condensed, don't let the fact that there's a fraction there scare you. It's not going to be any more involved than the other one. And you might say, well, that's what I'm afraid of. Okay. There's not a base showing, so what little base do we assume is right here? 10. A 10. So to cancel out that logarithm, we put a big 10 on each side. All of that goes. And we just have 7x plus 9 over x minus 2 equals. Notice how that 1 became the exponent. 10 to the 1 power is 10 to the first power. Is that just a 10? No, 10 to the first is just 10, right? 10 squared would be 100. So this 10 to the first power, I'm writing just as a 10. And we're not going to have to do any factoring here. This is just going to be we called it a rational equation way back at the beginning of the semester. I wrote it as over 1 because I'm about to cross multiply. We'd have 10x minus 20 equals, what's on the other side? 7x plus 9 would just times 1, just 7x plus 9. Now, notice there's no x squares. It's just a linear function, a linear equation. So just isolate the x. Move the stuff around like that. I'm subtracting the 7x and I'm adding the 20. 10x minus 7x, is that going to give me a 3x on the left? And what number on the right? 29. Then divide both sides by 3. Hmm. 29 over 3, that's almost a 30 over 3, so it's almost a 10. If you plug a number close to 10 in here for x, you're not going to get a negative number after it. Again, it's primarily if you get a negative answer, you better watch out. Well, you might have to mark it out. So 29 over 3.
So any number below 10 will give us a negative?
Oh, no, I mean, I guess if you'd gotten a 1, that's supposed to be gotten 0 as the answer. If you put a 0 into the first logarithm, that wouldn't give you a negative number there, would it? But right here, if you put a 0 in for x, that would give us a negative number, wouldn't it? Also, what if I'd put if the answer had been a 1? 1 minus 2. So really the answer needed to be bigger than a 2, so you get a positive number here. Okay? But again, primarily for you ought to be concerned, if you get a negative answer, mark it out. Okay? So 29 over 3. Oops. There. Problem 8. This one's sort of like the first problem number 5, I believe, because it has logarithm plus logarithm equals number. We don't have to move anything around. Let me write this down. Log base 2 of x plus 7 plus log base 2 of x minus 7 equals 5. Log base 2 of x plus 7 plus log base 2 of x minus 7 equals 5. Well, we don't have that first step that we had to do on number 7, move the logarithm over. It already has the 2 logarithms on the left, a number on the right, so I claim it's going to be like number 6. We condense it down to 1 logarithm. Will there be a fraction bar? No. Okay? If this plus right here had been a minus, then there'd be a fraction bar. But it's just log base 2 of x plus 7 times x minus 7 equals 5. Now, so I condensed them. How will I cancel out this log base 2? Yeah, big O 2 to both sides. And it's going to be a little bit messy because we have this x plus 7 times x minus 7. It's one of those algebra words that starts with an F. What am I going to have to do here? Foil it out. That's right. So I'm foiling this stuff out. But I think a lot's going to subtract out. We'd have x squared. Oh, let me lift this up. X squared, then a minus 7x and a plus 7x. See, those are subtracting out. And then what is that? A minus 49 equals, don't say 10. 2 to the 5th. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 1 more 2 is 32. 2 to the 5th is 32. Okay. So the 7x's have canceled out or subtracted out. I think probably the easiest way to solve this is just to move the 49 over here. 32 plus 49, is that going to be a 81? So can y'all look at that and tell me what's x going to be? 9. And if you're thinking, well, wait, what about negative 9? No. No negative 9 because, well, negative 9 times negative 9 is 81. It would make us a negative 9 plus 7 gives you a negative number after the logarithm. And sure makes it negative here. So only the number 9 is our answer. Okay. Y'all see all that, the way I foiled this out? We canceled out the logarithm by putting the big 2. And we foil out. 2 to the 5th is 32. So just move the numbers on the right and you have x squared equals 81. Everyone's problem is going to work out with this little perfect square there, but you only take the positive square root, not the negative. Okay? 9. Okay, we're slowly making it through. Okay. Number 9 looks worse than it is. Log base 5 of log base 5 of z equals 0. Log base 5 of log base 5 of z equals 0. There's just this one variable. We've got to isolate that variable. And we're going to do that by peeling away canceling out the logarithms, starting with this first black log base 5. What black number would I need to put right here to cancel that out? Okay. There. That still leaves me the blue log base 5 of z. And over here on the right, 5 to the 0, don't say 0. It's one of those rules of logarithms. 1, 5 to the 0 power is 1. We stated that a week ago when we were working with our... Anything to the 0 power is 1. 5 to the 0 power is 1. Oh, I didn't write down the 1. Why don't let me not write down the 1? Well, we're almost finished with it. I want to just have z equals a number. I'm isolating the z. So what blue number do I need to put right here to cancel out that log base 5? Yeah, another 5. This is a problem that looks much worse than it actually is. Heck, if you just look at the finished product, what I have written here, oh my gosh. Now this is this is a 5 to the 1 power, which is what answer? 5. Huh. So see how I sort of just canceled out each logarithm. You might say, well, wait a minute, how is that different from the other ones? There's only one variable here. Okay? In the other ones, there's 2 variables. Well, the x is appearing twice. Like it's not log 2, unlike over here. Log 5, log 5. There's only one more problem. Once you get to number 11, it's just review from there to get us up to 15 problems. Oh, okay, hold on. There? So I canceled the black log base 5 by putting a black 5 on each side. That's a 5 to the 0. That's where you're getting the 1. Then I cancel the blue log base 5. Just looking at the finished product, what the heck is he doing? This is one of those things where you sort of got to see me writing it out. That's the purpose of the videos. So 5. Check it. And then number 10. I wanted a problem, one more problem, just like number 6. You see, This is number 6. Don't write this one down. By the way, these little numbers up here identify. It's the unique identifying thing. It's copied from a book that isn't one of y'all's books. And this one's like same thing. Oh, I hope it's not the exact same numbers, is it? If your number 10 turns out to be exactly like number 6, do similar problem and get a different one. As if anyone would do that. Log base 6 of x plus log base 6 of x minus 5 equals 2. Well, we already have 2 logarithms on the left, a number on the right, so just condense this down to 1 logarithm. And hopefully you see how this one differs from number 9. It didn't say log 6, log 6. Okay? We have 2 separate logarithms. So how would I condense those? I'm going to write log base 6. Will there be a fraction bar? No fraction bar. If that plus had been a minus, there'd be a fraction bar. Now, let's cancel out this 1 logarithm. I'll put a 6 on each side. And we have x squared minus 5. Oh, duh. Jacob isn't in here to tell me change the screen there. Sorry about that. Okay, I'll just talk my way through. Start off by condensing them. So it's log base 6 of x times x minus 5. If that plus had been a minus sign, we would have put a fraction bar. Then we cancel out the logarithm by putting a big 6 on each side. And on the right-hand side, what is this number? 6 squared is 36. Just like problem 6, this is a quadratic equation. So let's move that 36 over to get a 0. How did I know it was a quadratic? Because of the x squared. So I have x squared minus 5x minus 36 equals 0. What numbers multiply together to give 36? There's 1 times 36, 2 times 18, 3 times 12. If I call out the pair that's going to work, let me know. 4 times 9 and 6 times 6. 4, 9. So I'll draw my 2 sets of parentheses. X and x. 4 and 9. I need these numbers to multiply together to give a negative 36. So that's a positive and a negative. How should I arrange the plus and the minus? Perfect. Plus 4, minus 9. Set each one of these factors to 0. And we get a negative 4 and a positive 9. Am I going to type both of those numbers in? Now, which one am I going to mark out? Negative 4. You can't take the log of a negative number. On problem 6 was the answer 9? No, on problem 6 the answer was 20. Okay, for some reason I was thinking it was 9, but no, I'm remembering wrong. Let me just punch it in so you see it's the correct answer. Then I will come over here. Okay. Remember, you can't take the log of a negative number. So that's why we're marking out the -4 answer. Okay. Any questions there? Any questions? Oh. Once we get to number 11, it's just review of other stuff. Let me just check and make sure that I'm right. Oh, okay. Let's see, number 11. Oh, yes. Do I remember the stuff about domains? The domain of f is equal to the range of f inverse. The range of f is equal to the domain. Yeah. Okay. Well, anyway, so we're through with this for today. I'm going to stop the recording, and if you have any questions to ask that you don't want recorded, just let me know.